Okay, today what we're going to do is we're going to be graphing systems of equations. So first thing you need to know is what are systems of equations? Well, systems of equations is where we have two lines and we're trying to determine, or two or more lines, where you're trying to determine how many solutions that has, right? So when you're doing this, you have different choices for how many solutions you have. You have one solution, infinite solution, and you have no solution. And you'll see all of these different ways, but just kind of put some examples up here as to what they are when they're one solution, what they look like when they're infinite solution, and what they look like when they're no solutions. And what you notice is with one solution, okay, you have different slopes, and you may or may not have the same y-intercept, okay? So when you do one solution, you're gonna have different slopes here. If you're looking at infinite solutions, it's going to essentially be the same line, right? 2x plus 2y equals 4 is the same thing as x plus y equals 2. This is just the reduced version of this. So that's what you're going to be looking for infinite solutions. No solutions, notice how the slopes are the same, but the y-intercepts are different. These are parallel lines. When you have no solutions, when you're dealing with systems of equations, you're going to have parallel lines for here. Okay? So these are what the equations look like. We're going to talk a little bit about what it looks like when you graph them here in just a second. But the other thing that I want to talk about is these two are considered what is called consistent because they have a solution. This one is inconsistent because there is no solution to this one. So no solution is inconsistent, infinite and one solution, both consistent, all right? Now, they also talk a little bit about independent and dependent. I'm not gonna go into that, mainly because I don't want it to confuse you with independent and dependent variables. So, well, I'm not gonna deal with that right now. We may come back to that later on, don't know. Okay, so here's what they look like on the graph. And this is a really good example, not really example, but reference sheet. There we go. Really good reference sheet for you in order to be able to see. So you might want this, all right? So number of solutions, exactly one. Again, we have an example of the equations, what they might look like, okay? Is called consistent and independent. And I'm more worried about you knowing that it's consistent here. But then if you look at the graph, where they cross at exactly one point, that one point is the solution to these inequalities, where they're both true. That's what you're looking at. Is where are they both true? Okay? Infinite solution, well, you look at it and you go, well, there's only one line in there. Well, no, there's two. They're just the same line. Okay? So they're going to be consistent all the way through. It's an infinite solution. Any point along that line is where it's going to be true for both of your equations. And then you have no solution. No, it's inconsistent. See how they're parallel? They're never going to touch. They're never going to have a solution where it's true for both of them. That's what you're looking at when you're looking at the possible solutions of systems of equations. Now, we're going to take this and we're going to kind of solve this, and I'm going to blow that up so we can see that a little bit better. How's that? All right. So here we have used graphing to solve the following systems. So we have two equations of our lines. One's in standard form, one's in slope-intercept. We don't care about that. That's fine. It's perfectly fine if one's in one form and one's in another. We're still going to use this in order to do this. We just need to be able to graph both our lines. Well, no problem. Here, first fill in the table for each equation. So we're going to set up t-charts. We've done this before. We know how to set up t-charts. If it's in standard form, 9x minus 3y equals 9, the easiest way to set up just a couple of points so that you can graph it is to use your x and y intercepts. So that's what we're going to use. We're going to use our x and y intercepts. So what we're going to do is use 0, and comma 0, and we're going to substitute these in to solve. So if I take 0 and plug it into x. 9 times 0 minus 3y equals 9. And all I'm doing is getting 2 points so that I can graph this. That's what we're doing. Okay? 9 times 0 is 0. Minus 3y equals 9. Okay? 0 minus 3y is still negative 3y. So we got negative 3y equals 9. Divide by negative 3. Divide by negative 3. Y equals negative 3. So when x is 0, y is negative 3. And again, we should be proficient at this point if we're starting to do systems of equations. Okay? So my first point is going to be 0 comma negative 3. No big deal. Now we're going to substitute in 0 for y. Same setup, same thing. Okay? Sorry. 9x minus 3 times 0 equals 9. And at this point you might be saying, oh, well I can skip this point because I know I'm going to just have 9x left. You're right, and that's fine. If you see that, that's fine. If you don't see that, just substitute it in and follow your steps. 9x minus 0 equals 9. Okay, 9x minus 0 gets you 9x. Divide by 9, divide by 9, x equals 1. Okay, so over here, my other point is this. So the first little part of this is no big deal. We have our points. 0, negative 3, and 1, 0. So 0, negative 3, 1, 0. All right? And now we're going to do the same thing over here, except now what I'm going to be doing is this is in slope-intercept form. Well, slope-intercept form, we want to create our t-chart. We're going to plug in numbers for x to find out what our y is. Okay, so we got negative, and I'm going to use the first one's the easy one, 0, right? Negative 0 plus 1. Well, if my first number is 0, negative 0 times this becomes y equals 1, because 1 plus 0 is 1. Doesn't matter this thing. Okay? There's my first point. Then I'm going to pick another point that I can find. Okay? So I'm going to use, and I keep it simple. There's no reason to make it hard. Use 1. Substitute it in. Okay? Y equals negative 1 plus 1. Well, negative 1 plus 1, y equals 0. Great. Now I have my 2 points. Keep them simple. It doesn't have to be hard. Okay? Now I'm just going to plug these two in here. 0, 1, 1, 0. All right, now I need to graph these points. Okay, so for my first line, and I'm going to write these down so that I don't mess them up whenever I graph it, because I'm going to scroll up here and not be able to see them. So my first point, 0 comma negative 3. This is on one line, 1 comma 0. And then on my other line, 0 comma 1, 1 comma 0. These are my 2 lines, okay? And I'm about to graph. Guess I could have left them over there. Now we have our line, our graph that we want to graph. So 0 comma negative 3, 0, negative 3, 1 comma 0. See how I have my first line right there? Okay, that's good, that's what we want. And then we're going to come over here and graph this. 0 comma 1, 0 comma 1, and 1 comma 0. And actually, we already knew where they met because look here. I had my 2 points there that it was the same. So the solution to this is one solution, okay? And it's where these 2 lines intersect. 1 comma 0. That is my solution to both of these, where they're both true. That's what we're looking for. Where are they both true? Okay? Well, they're both true at right here where they intersect. All right? Green dot, I'm good. Now I'm going to come here. What is the system solution? Well, it's right there. That's our ordered pair. That's where they met, right here. Okay? So make sure it's in there. Now notice here, you have no solution in infinite points. Okay? That's no solution. That's infinite solution. So if it's parallel lines, no solution. If it turns out to be the same line, it's infinite points. But this had one point where they intersected, 1 comma 0. A little bit of work in these, but most of it is just finding points so that you can graph your line. That's all it is. I mean, most of us could have graphed off of that, but that's all it was. Okay, it's not crazy hard, but you got to understand what you're looking at. Otherwise, you're going to get lost in it. Okay, let's do another one of these. I want to make sure we know how to do these. Okay. Let's find one. Okay. Notice this. Look, y equals 2x minus 1, y equals negative x plus 2. They're both in slope-intercept form. Substitute x's. Get out your y's. Okay. Standard form. Slope-intercept form. Oh, let's do that one. Yeah, let's do that one. All right. You have a couple options here. First off, you could convert this to slope-intercept form if you'd like. If you'd like to do that, that's fine. I'm going to show you basically the same way I did before, where I plug in my y-intercepts, or my intercepts, and have my 2 points that way, and go from there, okay? So, x plus y equals 1. If I substitute in 0 for x, that's y plus 0, so y equals 1. So my first point, 0, comma 1. My second point, plug in 0 here, plug in 0 for y, I get out 1. 0, comma 1, 1, comma 0. No big deal. 0, comma 1. 1, comma 0. That's fine. Now I'm going to do the same thing. Okay, again, let's keep it simple. Plug in 0 here, y equals 1. Okay. And then let's use 1. Plug in 1, get out 0. What do you notice about your points? They're exactly the same. Okay? They're the same. 1. So you should know what your lines are going to look like. 1. Okay? So 0, 1 and 1, 0. And then you end up doing it again. 0, 1. Okay, so it took both. Now, I don't know if you can just do the one line and then hit the number or not, but notice, you only have the one line, they're exactly the same, so this is infinite points, right? Exactly the same line. That's what you're looking at. Now, I'm hoping that when you saw this, you might have been able to see that right off the bat. Okay? That's what I'm hoping. But if you couldn't, do your ordered pairs, substitute them in, graph it, and then pick the correct one. Okay? That's what you're looking at. All right? Let's see if there's any others that we want to do. All right. X equals 0. So x is always going to be 0 no matter what the y is. Okay? So if x equals 0, that means that this x is 0. Okay? And then you can put in any number for the y, and then now all you got to do is get get points off of this and have it. And you'll be able to plug it in here. Okay? So if you can do that, you're going to be good. I think that is all for those. Yeah, same thing there. Plug in the y. Our y is always going to be 1. Okay? You got to be able to graph those. You should be able to do this. Okay, we've done plenty of graphing. All right. Next thing. 2 lines graphed on the coordinate grid, each represent an equation. So we have systems of equations. Okay? We have a solution set right there, okay? Where they are both true. The solution to our systems of equations is right here at 5, 4. 5, 4. It's that point right there where they both cross. Okay? What is the ordered pair that represents a solution to both equations? That's what we just found. So, in here, 5, 4. There we go. Now, how do you know that that point is a solution to the following 2 equations, which are shown in the graph? And then they give you these lists of what you're looking at. Look, this is an x, this is a y. Okay? You're going to substitute these back into each one of these. Okay? Now, first, read these to make sure that they don't say, oh, that's where the 2 lines cross. Because sometimes it says that, and that's the reason you know, right? But if it doesn't say those, which none of these do, okay, it says because it's where both lines cross the x-axis. No, that's not true. Okay? Because 3 times 5 minus 11 equals 4, and negative 1 times 5 plus 9 equals 4. Let's substitute these in and see, right? Okay, so into this first one. 4 equals 3 times 5 minus 11. That's the first one, okay? And the next one is 4 equals negative x, or negative 1 times 5 plus 9. Okay? Now, which one of these represents these 2 things, right? Well, because 3 times 5 minus 11 equals 4, Okay, so this first part, it's good, right? And negative 1 times 5, well, negative 1 times 5, yeah, plus 9 equals 4, Ooh, I like that one. It's that one right there, okay? But let's check these other ones to see if what they are saying makes sense in the context of what we have, right? Because 3 times 0 minus 11 equals negative 11. Well, that doesn't even make sense in context of what we have here, okay? Negative 1 times 0 plus 9 equals 9. Yeah, see, none of that makes sense in what we're looking at, okay? Because we need to know, how do we know this is the solution to both of these, where they both do? Well, that means that when we plug that number both into both of these equations, we're going to get true statements out of them. That's what we're looking for, because we had one solution set, and that's what we're looking to get out of here. Okay, so neither one of these make any sense in the context that we're looking for. That's not even true for us in this instance. So that's what we're looking to do. Okay, so again, check to see, is this where both lines intersect each other, or if you need to substitute it in here to see which one goes. Okay, not that hard. This skill set right here is not that hard, but it is a very important one for you. Okay, you got to be able to recognize where is the solution set for this system. Okay, right here. Can you graph it, and can you tell me why? Very important skill. Okay? You're going to see this moving forward. Okay? This one just asks, where is the solution? That's all it is. All right? Again, same thing. Right there. Okay? And how do you know? Substitute in your number back into these equations and determine which one is true. Okay? Again, not crazy hard, just it has a little bit of work involved in it. Okay? If you have any questions over this, you need any help, okay, remember to look at these so that you know what you're looking at. The other thing to look at is this. This is really good. Okay? And if you need any help, let me know.